This problem asks to find the volume of the region outside the cone, phi is equal to pi over 3, and inside this shape, rho is equal to 6 cosine of phi. And I wanted to start off by graphing this rho is equal to 6 cosine phi because I think it's a little bit less intuitive. So I wanted to start off with a very similar function which is in polar, which would be r is equal to 6 cosine of theta. And just one thing I wanted to note is that the domain of phi only goes between 0 and pi. So I'm going to limit myself for my theta as well, because again, I'm just trying to draw what I would consider an equivalent drawing. So again, let's let theta in this graph go between 0 and pi. So if we, again, wanted to graph this, we might choose values of, when we're trying to find our r, we would choose values of theta. So I'm thinking here, if I had theta equals 0, and then pi over 2, and then going all the way up to pi. And if I calculated r, so cosine of 0 is going to give me a positive 6. And so it's sometimes helpful just to draw the cosine graph with respect to r and theta before you try to put it on an xy graph. And so over here I have this xy coordinate system, and again we have the point 0, 6, and then when theta is equal to pi over 2, we can see we're at 0. And if we wanted some intermediate values such as pi over 4, so that's the cosine of that will be root 2 over 2, and I get 6 times square root 2 over 2 is equal to 3 root 2. And square root of 2 is about 1.4, so we're going to say this is approximately 4.2. So if I start here graphing and count over at theta is equal to 0, then I have this point here at 6, 0. And then as I let my theta increase again as I'm going out along this pi over 4 line, I'm out at 4.2 units. So that's going to be about there. So this is about 4 units and a little more. And then when I get to pi over 2, I'm back at 0 again. So this is going to trace a circle. And then when I complete this going up to pi, 3 pi over 4. So again, I'm imagining this 3 pi over 4 for theta extends this way, but the radius this time is going to be 6 times the negative root 2 over 2. So negative 6 root 2 over 2 is approximately a negative 4.2. And then the cosine of pi is going to give us negative 1, so this value of r is going to be negative 6. And so again, when I have my pointer going out in this direction, it means then that I have reflected back and come back to this point. So reflecting from pi over 4, or 3 pi over 4 backwards to this point, I trace this part of the circle, and finally the remaining part of the circle is drawn in that direction. And we can see this actually if we graph something here. You can see r is equal to 6 cosine theta, and it looks like, again, a circle that's in the first and fourth quadrants. So when I make this equivalence with phi, phi also is going to be a circle, but just to remind myself, so when I'm trying to find my rho based on certain values of phi, again, when phi is equal to 0, then my rho will be 6, and when, in fact, I'll just copy this over, pi over 4, then we get about 4.2, and at pi over 2, when phi is pi over 2, we get back to 0. And then we're actually not going to worry about the negative values of phi. So what happens is phi is that angle that's from the positive z-axis. So let me draw my coordinate axes. And when I, again, pull this angle phi, when I start out, when phi is equal to 0, so when I'm straight up on the z-axis, I'm going to have a row of 6, so this is going to go up 6 units. when phi is equal to pi over 4, so that's over here, then we end up with that length rho of about 4.2. And then when we get to pi over 2, we're back at 0 again. So that's going to draw the right half of this circle. But one thing to remember is that this shape here has no boundaries on rho. And because it has no, it has no boundaries on theta. And because it doesn't, in this, for this shape, our theta is going to go between 0 and 2 pi. And what that means is that if you think of the z-axis, as the center, this circle is going to spin around. So this half circle will spin all the way around. And what that means is it's going to fill out the sphere, so it looks like that. And so we have this sphere, again, that goes 360 degrees all the way around. And then when we imagine what's going on with the cone, so for the cone, we have this phi is equal to pi over 3, which is 60 degrees, so it's actually further than halfway down. And again, that angle is pi over 3. But this also, if you think of it as just a single ray, this also is going to spin all the way around. And as it spins around, it's kind of like you have a ball of ice cream, and then you have one of those ice cream scoopers where that little wire goes around. But this time the wire is not curved, it's straight, and so it's going to go all the way around the circle, and it cuts out this cone. So if we look at this shape in the RZ plane, we're going to see then that we have the semicircle and we have the ray. And again, because this angle is pi over 3, that means that this angle down here, the smaller angle, is pi over 6, or 30 degrees. So when it says to find the volume of the region outside the cone and inside this sphere, outside the cone and inside the sphere is going to be this region here. And again, it's not just in a plane, because we are going to rotate it all the way around the circle. So we have essentially carved ourselves out maybe like the inside of a flower if you had straight sides, but the outside is curved. And so you've got this space inside which is cone-shaped, but the outside is spherical.